So in the today's session, we are going to discuss the basic concepts of data warehousing, and uh, and also I'll explain what is the curriculum, what are going to cover as part of the course. Okay. So here, let me come to the curriculum part. The first thing is we have to know about the data warehousing concepts. These are completely theoretical concepts. So data warehousing concepts. So these are very much required. So as part of this, we are going to learn what is data warehousing, what are the features, and what are OLTP and OLAP systems. So what is the difference between database and data warehouse testing? So these are the different topics we are going to see as part of data warehousing concepts. And then we will see ETL testing concepts, like ETL concepts. These are not actually ETL testing. So ETL concepts are different. Now, once we discuss about data warehousing concepts, let us move on to the ETL concept. So, what is ETL again? What are the different types of data load in ETL? And what are the different terminologies we use as part of ETL testing, right? So, and data cleansing, data masking, data retention. So, these are the different technical terms which we need to have some idea. Okay. So, then we will discuss about the ETL concepts, and as part of this, we are also going to discuss about the ETL process. This is basically high level curriculum. I'll send you the 4 weeks complete curriculum to you. So this is high level what I'm going to cover as part of ETL testing. Okay. So then we will see ETL process. So as part of ETL process, where we need to start, what are the input document required, and how we need to write tests, ETL test scenarios and test cases, how we need to do execution part, defects. So these are the different concepts which we are covering as part of the ETL process. And then we are going to learn a tool called this is basically ETL tool, query search. This is become a very popular tool available in the market. This tool we can use it for ETL testing and is also used for Hadoop testing. Okay, so basically it is very much popular for ETL testing. So these are the different concepts we are going to cover as part of this course. And especially today's session, I'm going to cover the first two things like data warehousing concepts and ETL concepts. So once we are familiar with this, we are going to learn about the SQL part. So because before entering to the ETL testing, we have to know the SQL, like advanced SQL, like normal subqueries like joins and so on. So little bit advanced concepts we required for before going to ETL testing. So that's the reason SQL is also incorporating this particular curriculum. Okay, so once we are familiar with the SQL part, and then we will move on to the ETL testing process and the tool. So this is how the high level curriculum has been designed. So in the detailed curriculum, I'll send you today. So now let us start with this session. So what is as per today's class, we are going to cover again data warehousing concepts and then ETL concepts. Okay. Now let us start with this. The first thing is, what is data warehouse? What is data warehouse? So basically the term database is different, data warehouse is different, right? So what is database? Basically the database is a collection of data. So whatever data we have from the application, whatever data we are getting, so that data will be stored in the databases, right? But what is a data warehouse? What is the difference between database and the data warehouse? So let me show you a picturized format. Just a moment. What is database and what is the database? So how the data will be stored in database, and then how data will be stored in the data warehouse. So just a moment. Let me open the whiteboard. Right. So now let us see what is the difference between database and data warehouse. Actually, where the data warehouse coming to the picture. So here in the real time, we are always users are interacting with the application. So for example, let us say a bank. Okay, some bank. So this bank is having a different branches in different locations. So for example, location 1 and another location 2 and the other location 3. So there are different branches we have. So customers are coming and interacting with the they are doing certain kind of transactions, right? So in each and every location, and the bank actually want to get the data for analysis purpose. right? How many new customers are joining, like how many are going back, and how many employees are recently, how much transactions are happening per day. So this kind of information they require. So this is basically called as analysis, right? So every location those things are happening, right? But every quarter or some period of time, actual bank is going to bank would like to want to know the what are the things are happening in this as an analytical point of view. Okay, so they get this data from all the locations and put together in one place. Okay, so this is basically called as a data warehouse. This is data warehouse. So the bank is using this particular data for analytical purpose, not for transaction purpose. Okay, but each and every location there will be again database will be there. So actual the transaction will be happen in this local databases. Okay, so but these databases having the data which is called as transactional data, the transactional data, and day to day basis the data will be updating. And when you come to the data warehouse, but this is not, this is also a kind of transactional data, but at the quarter or 6 months once we will take the entire data from all the branches and put together in one place. So this data will be used for analytical purpose. So wherever we store all the data, collected data in one place, the data, the storage area, this is, that is called as a data warehouse. Okay, so this is basically concept of data warehousing. So data warehousing means combines the data from multiple various sources into one place. So this data can be modified, updated, edited for analytical purpose. Okay, so why we need to use this data? For analysis purpose or for reporting purpose. So here again we will use some business intelligence tool for getting the reports based upon this data. This is basically data warehouse. Okay, so that is the basic concept of data warehouse. Now we'll move on to this other one, the data warehouse. So what is the data warehouse? How we can define data warehousing? Data warehousing, I'm writing the notes here, combines, data warehouse combines the data from multiple sources into database, in one database, which can be used for analytical or analysis purpose. So this is basically called as data warehouse. The actual data will be loaded into one place. So that is called as a data warehouse. Now, so let us see what are the different features of this data warehouse, like what kind of data it should have. So basically, if you come here in the data warehouse, the data will be the subject oriented. So what is subject oriented? Because the same kind of data we have to get. So how we need to derive the data here, for example. So let me draw one more diagram here. So I have other location here, different location 1, location 2, and the location 3. Three different locations I have. So all these locations I'm getting the data in data warehouse in one place. Okay. Now this data warehouse data can be used for reporting purpose. Just a moment, please hold on. Okay, sorry guys. Okay, so now let us see a scenario here. So here we have a multiple locations and we get the data from multiple sources and put together in one place. This is called as a data warehouse. We are calling as a data warehouse. So how this data will be? So this data is basically a subject oriented. So what is subject oriented? So this data can be used to analyze particular area. So for example, if I take the bank, right? So if you want to analyze how many customers are joining per quarter, okay, so how many number of transactions are happening per day? So this is a kind of subject oriented, right? A specific kind of data. So this data will be the specific kind of data that is basically called as subject oriented. And this is integrated data. So we are integrating the data from the multiple sources in one place, right? So this is basically integrated data, and this data will be the time variant. What is time variant? Because this is a historical data, not a live data, right? So for example, there are three different locations here. Multiple data sources are maintaining in the local locations, and here the transaction, temporary transactions are currently, the live transactions are stored in the local databases, right? But every 3 months or 6 months once, what we will do is we will dump the entire data into the one place. So what does it mean? This is historical data. Basically, this is historical data. So historical data means long back data, right? So based upon this data, we will analyze and then we will generate some reports, because we will know the company growth and all, right? So this is a time variant. So again, after 6 months, again we will dump the data. After 3 or 6 months, again we will get the fresh data. Again we'll do some analytics. So this is how we need to do. And this is non-volatile data. So what is non-volatile? Volatile means always keep on changing. So non-volatile means it will not change. So once we dump this data, next 3 to 6 months, the data will be the static. This data should not be changed, because we need to get some reports. We need to generate some reports. We need to do some analysis on this data. So that's the reason we should not change this data. Once we put here, we should not update, we should not edit, we should not delete. No DML operation should be done on the should not be done on the data warehouse. So that is the reason we call this as a non-volatile data. So the data can be, these are the basic features of data warehouse data. Like it is subject oriented, and it is integrated data, and it is time variant. Time variant means it maintains the historical data, and it is a non-volatile. Non-volatile means we cannot modify any data, because this is used for analytical purpose. Okay, so now let us see the features of uh, data warehouse. Features of data warehouse. Features of data warehouse. So as I said, it is a subject oriented, right? The first of all, it is subject oriented. Why we are called subject oriented? Because we will get the same kind of data. Subject oriented, specific to some particular subject. For example, customer, sales, right? Transactions. These are all different kinds of data. So subject oriented data we will get in the data warehouse, and the data is integrated data. It is purely integrated. So we get the data from the multiple sources, right? So that is a integrated data. And the data is a time variant. Time variant means every 3 months or 6 months the data will be changing, because every time we need to dump the data from the sources to data warehouse. So this is a time variant data. Time variant. And this is a non-volatile, because the data should not be changed. This is non-volatile. Right. So these are the basic features or characteristics of data warehouse. Now let us understand what is yeah, Sandeep, what is the question? Please type on the chat if you have any questions. Sandeep. Okay, time variant means what about previous data? So basically in the data warehouse, we should not maintain a long back data. Okay, so because there is some period of time. For example, some companies will change the data every 3 months or 6 months, or sometimes years, 2 years, 5 years, and some companies they maintain the data in 10 years. Okay, so this is basically the data warehouse. Okay, so this data can be used for reporting, right? So once they have analyzed the reports and everything, then after 3 months or 6 months, they can again dump the data. Okay, sometimes what happens is if they want to have the old data, they can keep the data again, and the refresh data again loaded. Sometimes what will happen is, suppose some customer, for example bank, let us say some example like bank customer. So in the records, the bank customer is updated his address. Okay, so after 2 years or 3 years, he has changed the address. So he updated the at the branch level, then the data is dumped into the data warehouse. Now in the data warehouse, what is the address will be there? in the previous address and the new address, both we need to maintain, right? So in that case, in the data warehouse, what we will do is, instead of removing the record, what we will do is we will maintain the old record. At the same time, we will also maintain the updated record. There will be the two entries. Okay, so here slowly dimension SGD types will be coming to the picture. So there are few cases there we should not remove all the data. We should keep the data whichever required, and rest of the data will be completely removed, and the fresh data will be loaded into the data warehouse. Okay. So now let us see. There are two terms are very important here. We need to understand: OLTP and OLAP. Online transaction processing, online analytical processing. These are the two important terms which we need to understand first. Online transaction, sorry, just a moment. Online transaction processing. And what is OLAP? OLAP means online analytical processing. Online analytical processing. So what is the difference between these two? Online transaction processing, online analytical processing. So basically, OLTP is nothing but a database which actually stores the daily transaction, which is called as a current data. So as I said here, in different locations, different databases will be maintained, right? So these databases having the current data, right? The present data. So these are the systems called as basically online transaction processing. So these are the databases can be used as OLTP systems, called as OLTP systems, online transaction processing. But this data is a temporary data. So on day-to-day basis, the transactional database will be updated. Okay. And the customer information, data, and everything will be updated in the databases. That is online transaction processing. On day-to-day basis, the databases data will be keep on changing. When you come to the OLAP, online transaction and online uh, analytical data, basically it will talk to the analytical data, online analytical processing. So what is OLAP here? The data warehouse is called OLAP, because this data can be used for analysis, right? So here called as OLAP, online analytical processing. And when you come to here, this is called as OLTP, online transaction processing. Online transaction processing. This is the one difference between OLTP and OLAP. So usually the OLTP is used for more of online applications, where the application needs to update very frequently in order to maintain the consistency in the data. Okay, so this is temporary data. So because every location, these databases will be maintained. This is basically called as OLTP, online transaction processing. And data warehouse basically called as OLAP, online analytical processing. Okay, and let us see what is the difference between these two. And one more important thing is, here in OLAP, the data will be managed with everything is a normalized. So what is normalization here? There are some tables. So what is database? Basically, database contains multiple tables, right? So actually data will be stored in the database tables. So there are some tables are linking, right? The data whenever we get the data, we are getting the data from multiple tables. That means we are integrating this table. We need to maintain some relationship between the tables, right? So if you want to get data, uh, and if you want to avoid the duplications and all, we will apply some normal forms. Normalization in the sense we need to apply certain rules on the relations. So this will be there in the OLTP systems. When you come to the data warehouse, here the data will be denormalized, because there is no relationship at all, because we are getting the data from the multiple sources, not from one source, right? So that is the reason here the data is completely denormalized data, and these data can be used for analysis purpose and reporting purpose. Okay, and there are few differences between these two. Let me show you the what are the differences between OLAP and versus OLTP. So let us see, involves historical processing of information. As I've said, OLEP is nothing but for analysis purpose or analytical purpose, right? So this data is basically historical processing of information. So it maintains some history. Okay. And when you come to the OLTP, it involves day-to-day processing. So every branch on every location on day-to-day basis, transaction will be stored on the OLTP systems. And when you come to the data warehouse, OLEP systems are used by knowledge workers such as executives like managers and analysts. See, as I said, this is for analytical processing, right? It requires certain kind of intelligence, like analysis is very much required. So a few people responsible for this actually. The only nowadays people are doing the most of the people are using most type of analytical tools like Tableau, like Cognos, or so there are many number of tools are available in the market, right? So people should have some knowledge on the tools so to analyze the data. And when you come to the OLTP systems, they are used for by clerks, DBAs, or database professionals. Usually, when you come to any bank or some other organization, if you want to do some a certain transaction, they are not technical people basically, right? So they don't even know the what is happening at the back end. So just they are consider only the front end application, right? So here there is not much knowledge is required for this, and especially the DBAs and database professionals, they will manage this data. And when you come to the data warehouse, OLAP, again, useful in analyzing the business. So why we need to analyze the data again? Because we need to know the business process, right? So whether it is in profits or losses, so and where are we and where we need to go, we should specify some kind of milestones, right? So if you want to define that, first of all, we need to know where we are currently, right? For that, we require data analysis. So here the OLAP systems are useful for analyzing the business, and OLTP systems are useful for running the business. That is the difference. One is for analyzing, one is for running the business. So running the business means on the day-to-day basis, you need to go to the banks or some organization. You need to update the data. You will perform some transactions on online, right? The business is currently running at present, so the data should be maintained in some place. So OLTPs are responsible for running the business, whereas OLAP is responsible for analyze the business. That is a major difference. And here, data warehouse like OLEP is focuses on information out, and it focuses on data in. So what is the difference between these two? Out and in means, so whenever we do some transactions, the customer is coming and do the transaction. That is incoming, right? So when you come to the data warehouse, this is the output of multiple sources. So here we say like out. So we are already get the data from the customers. The data is available in the OLTP systems, but we get the data and put in one place for analysis. So that whatever data currently we have, that is outcome of the existing data. So it's completely focusing on information out. And then in OLAP, based upon star schema, snowflake schema, and constellation schema. So in going further, we are going to discuss about this. What are the different things we are going to use here? Because these are the different dimension schemas. We are calling as a dimension schemas. So it defines basically how we need to organize the data, how we need to place the data. So that will talk about different type of schemas. We are going to cover that part in coming classes. And then when you come to the OLTP, it is based upon entity relationship model. So we need to define the relationship between multiple tables, and we also store the data in the multiple tables and multiple columns. Whenever we retrieve the data, the same data can be retrieved from the multiple tables. And the data warehouse contains the historical data, right? So as I said before, this contains only historical data. It can be 3 months or 6 months, 1 year, and sometimes more than 1 year. And the operational database like OLTP systems contains the current data, existing data, and day-to-day basis data, right? So when the provides the summarized and consolidated data, OLTP is a consolidated data. It contains the fully summarized and consolidated data, because if you have summarized and consolidated, then only we can use it for analysis purpose. The other one is here in OLTP provides a primitive and highly detailed data. So primitive and highly detailed means, so it contains the detailed data basically. So if I have a customer, the customer including the customer transactions, location, so how many years have been with the bank. So this kind of information will be there. So it is highly detailed. Complete information is there, but we are getting the required information from the OLTP for analysis purpose. For analyzing the data, for analysis, we don't require the detailed data. Okay, for analysis, for analyzing the data, we require the basic like high level data is required, but each and individual data is we don't require. Okay, so that's the reason we are saying here is OLAP is summarized and consolidated data. When you come to the OLTP, it is provides a primitive and highly detailed data. The next point is OLAP provides a summarized and multi-dimensional view of data. So we will discuss this part in the coming classes. What is multi-dimensional and what is the different views of data we can see and all. And when you come to the OLTP, provides the detailed and flat relational view of data, just like a tabular format. We can see the data in the tabular format. And in OLAP, the number of users in is in hundreds. When you come to the OLTP, the number of users in thousands. Why? Because in OLTP, the day-to-day transactions happen. Any number of customers will come into the OLTP, right? But we don't take the, suppose in OLTP we have thousands of records. We don't require thousands of records we don't require for analysis purpose. We will get the only subjective data. So whatever data we required for analysis, only we will get the data. That's the reason when you compare to the OLTP systems data, OLAP systems data will be very much less. Okay, and then number of records accessed is in millions, and the number of records accessed is tens. See this. This is completely conflict, right? So here the ninth point, what it is talking is number of users is in 100. What does that mean? In OLAP, we have a minimum number of users, and when you come to the OLTP, number of users is thousands. And here we are talking about two things: number of users and number of records. Number of users and number of records. So here number of users in the sense whoever is analyzing the data. The users is talking about the data. Whoever is responsible for analyzing the data, they are called users. But record in the sense how much data it is stored in the databases. That is all about the record. So in the 10th point, they are talking about the records. So number of records accessed in millions, but when you come to the OLAP, the number of records accessed in tens. And when you compare to the size, the data warehouse size, it will be huge because it is contains the historical data, 3 months, 6 months, 1 year of data. So that's the reason it contains the GBs and TBs of data. But normal OLTP systems contains a less number of size. And performance wise, data warehouse highly flexible, and operational database should be provides high performance because OLTP number of people are interacting with the OLTP on day-to-day basis, right? Through online, if I do something, it should be maintain some performance speed, right? So that's the reason OLTP systems always designed with a good kind of performance. But when you come to the data warehouse, it is not much performance wise, it is not much compared to the OLTP, but it is highly flexible because we want to get the data for analysis purpose. We don't require that much of performance here. Okay, this is only one type job. So we can say these many differences between data warehouse and operational database. Operational database in this is a normal database, OLAP and OLTP, online application processing systems and online transactional processing systems. That is the difference between these two. Now let us see how the data warehouse seems like. So for example, let us see here. So the database warehouse is like this. The structure of the data warehouse is like this. For example, here I said data is coming from the multiple sources, right? This is for example source 1, application 1, application 2, application 3, and these are the 3 different applications. We can have n number of applications. So this data temporarily stored in the database. This is called as OLTP, and day-to-day transactions will be stored on this database. Online transaction processing. So these applications are directly interacting with this OLTP systems. And this data will be the completely row oriented and completely normalized data will be present. From this, we are getting the data through ETL and dump the data into the warehouse. So the warehouse here called as OLAP, online application processing. So here actual data will be stored. So we can do the ETL here on the daily basis or weekly basis or sometimes monthly basis based upon the organization requirement. Okay. So once ETL is done, what happens? The data, whichever is present in the OLTP systems, that data will be dumped into the OLAP systems, that is warehouse. And this warehouse contains the historical data, and we will use this data for analytical purpose. For generating the reports and analysis purpose, we can use this data warehouse data. Okay, so this is a typical data warehouse architecture. So here we have only one OLTP database, but in the real time we have many sources and multiple locations and multiple branches. So we will get all the data in one place. After doing ETL, we will get the data here. So this is basically called as data warehouse structure. Now we will see, as I said, what is the difference between database and data warehouse? Just now we're talking about, right? What is a database? Database contains is a collection of tables, right? That the OLTP system basically called as a databases. So and day-to-day transactions will be stored in the database. But whereas data warehouse different. Data warehouse contains the only historical data, not the day-to-day transactions. Okay, so database is example for OLTP. This is a basically database. Any database is example for OLTP. And for OLEP, what is an example for OLEP? Data warehouse. Data warehouse is example for OLEP. So it contains the historical data simply. And OLEP contains the day-to-day transactional data. That's the reason it is called transactional data, and this is analytical data. Right? So now let us move on to the ETL versus a database testing. So far, we know a few people will know what is database testing so far, right? But how ETL testing is different than database testing. So now let us understand this. So what is the scope of database testing, and what else we have to test as part of ETL testing? That difference we need to know the basically, right? So let us see ETL versus database testing. ETL versus database testing. So in database testing, what we need to test? In ETL testing, what we are going to test? If you see here, we cannot see much difference because both are testing the data. But even though they are focusing on the data, both are not the same. So in what case both are not the same? Because in database testing, so basically we will test the table schemas and data types and relationship between the tables, right? So what kind of data it is storing and the data types of the columns. So these are the things we are going to test as part of database testing. When you come to the ETL testing, here 100% focusing on the data. So once we dump the data from the source to target, that means database to data warehouse. In the data warehouse, the most important thing is here, we need to focusing on the data. So not on the relationships, okay, not on the table structures. Only we have to focus on the data. Okay, so whether the data is accurately loaded or not, that is the main focus. So there the ETL testing is difference when you compare to the database testing. Okay, so now what is ETL and database testing? So in database testing, the major focusing on in database testing. So we need to focus on what tables, relations, columns, like and data types, right, etc. So these are all the things we need to focus on when you do the database testing. So when you come to the ETL testing, in ETL testing, we need to focusing on only the data part. In ETL testing, we need to focus on data. The data is most important here. So we need to focus on data. So here the ETL testing, and database testing will be different, and we'll also see so many differences going further. As per the ETL testing, we will do lot many things which are not part of database testing. Okay, right. So now, any questions so far? Kavita, Sandeep, please confirm on the chat. So, are able to follow? Okay, good. Kavita, Kavita, are you there? Hello, Kavita, are you there? Okay, good. So fine. So now, if I ask something, just immediately respond to the chat. Okay. So please pay attention. Right. So now let us see data model. So because before going to the ETL testing, these are all very important for us. Even though this is theory, we have to know these things. Okay. So now let us discuss what is data model. What is data model? So basically the data model tells like how the logical structure of database is modeled. For example, we can say like if anything, suppose a new business have been started. For the new business, we need to uh, design a database. We need to have some database. So for example, if I take a shopping, so a store, okay. So we should maintain the data in some database. So what kind of tables which we need to have? For example, stores like customers, sales, prices. So this is all the different kinds of data we will get, right? So for storing this information, we need to define a tables first of all, and then we need to establish the relationship table, relation between the tables. Right? This is a step-by-step process. So here the data model defines how the logical structure of the database will be. If suppose if you want to design a database for an organization, so what kind of data they will get, that we need to focus on first. And based upon the data, we need to form a model. First of all, high level model we require. So here we have two different things model. So one is we say conceptual model, conceptual data model. I'll tell you what it is. The second is logical data model, logical data model, and then physical data model, physical data model. So let us see what is this. One, two, three. So first one is conceptual data model. The second one is logical data model, and third one is the physical data model. So what is data model? Data model tells how the logical structure of the database is modeled. Okay, so how the data will be, so that will be defined as a data model. So conceptual data model and the logical data model and the physical data model. So what is that? What is conceptual data model? Conceptual means it is high level. We don't know exactly internally what are the tables, what is the columns are required, what is the data it contains. We don't know anything. Just as a high level conceptual. For example, if I take a business or a store, a shopping mall, at the what is conceptual level here, because what we are know at present, we will know like what are the items are there in the shopping cart, items, customers, sales, right? This kind of data we require. So this is basically called conceptual data, conceptual data model. At the high level, we will think about the what kind of data will be, and the next level we need to form a different tables, and the third level we need to define a different fields or columns. So this is a step-by-step process, right? This is basically part of the database design. So here the conceptual model, the logical model, and the physical model. So what is the difference between this conceptual model, logical model, and the physical model? So these things are very important as part of the design. Conceptual model basically identifies a high level relationship between the entities. So what is entity? Customer is an entity, sale is entity, or like for item is an entity. So everything in an organization is an entity, right? So it will define the basic high level relationship between the entities. So basically here uh, conceptual data model means It displays the important entities and their relationship among them. Basic entities. What are the entities? For example, if I take the store, sale for item is entity, customer is entity, right? And the product is entity. So these are the different entities. And here we know only we need to identify only the entities at high level. But we don't know the what are attributes and what are the primary keys we need to define, or what are the other keys we need to define, what are the tables required, what are the column fields are required. We don't know anything. Just at high level, at the conceptual level, we know what kind of data will be. That is basically called as conceptual data model. So when you come to the conceptual data model, conceptual data model. So here there are three important points we need to remember. The first one is, here we need to define important entities and relationships among them. This is the first important thing we need to remember. First thing is, we need to define the high level entities and their relationship between them. So that is the first thing we need to define. And this is also contains, here we don't specify any attributes and don't specify any primary keys and nothing. Just only high level entities we need to identify. That's it. So here no attribute is specified. We don't specify any attributes. Here attribute on the sense, assume that table columns. Entities are nothing but a tables. Attributes are nothing but a columns. Okay. Fields are nothing but a data. So here entities, relationship, only entities and relationship, that we can understand, we can identify. There are no attributes are specified in this model, and there is no keys. No keys have been defined. Keys are nothing but primary key, foreign key, like unique key. There are some technical integrity constraints in database, right? So those keys we don't know here. So this is high level conceptual model. So it seems like this. See here, in an organization, these are the only thing entities we have, right? Products, time, sales, like customer, and the store. So these are the high level entities. In going further, these entities are become a tables. These entities are become a tables. So in conceptual model, we don't know anything which is there inside. We know only the high level conceptual wise entities. What are the entities we have? If any new business is started, if they want to design a database, first of all, they don't know anything. Only they know the what are entities we have. And based upon the entities, and then we will later move on to the other model. The first, the high level model is conceptual. Then little bit dig into this, and then we will define the logical data model based upon the conceptual data model. Okay. So in conceptual data model, only we need to identify the entities and relationships. Okay, that's it. Other than this, we don't have anything. And here we don't have attributes and don't, no keys are defined. Nothing is there except the entities. And when you come to the logical data model, we need to define few more. So then what is logical model? Logical data model. So in the logical data model, we need to define few more. Apart from the entities, we have attributes. Attributes also we need to define, but in the first conceptual model, we don't have attributes and the key. But when you come to the logical model, here we need to define, for each entity, there are certain attributes. So those attributes we need to define. And we need to also define a keys, like primary keys and foreign keys. These are also we need to define. And then we need to also do the normalization, because duplicates we should eliminate, right? The duplicate columns or duplicate data, multiple things we should not be clubbed together in one place. So we need to do some kind of normalization. So these things will happen in the logical level. So this is basically the background of database design, how the people will design the database. First, they design high level conceptual data. Based upon the conceptual data, they will identify the entities. And the second level, apart from the entities, they will also find out what are all entity, apart from the entities, for each entity, what are all the attributes and what are the keys they have to specify. So even that also they will identify as part of logical data model. So now here in the logical data model, here it include all the entities and relationship among them. So what does it mean? The first point, here also we have all the entities and relationships. Apart from this, we have all attributes for each entity or specified. Okay, so all attributes here, just assume that entity is nothing but a table, attribute is nothing but a table, column or field. Okay, so here apart from the entities we need to also define attributes. We should also define attributes. So that is the one level, and also we need to specify the keys like primary keys and foreign keys. So these are all things we need to define. So define keys. So this will happen at the second stage. So this is basically called as logical data model. So it seems like this, that this is a logical data. If you observe here, apart from these entities, product is an entity, date is an entity, sales is an entity, customer is an entity, stores is an entity, right? These are entities which are already defined earlier in conceptual model. But in logical model, we need to also define attributes. So for example here, product is an entity. For this, what are the attributes we have? Product number, product type, product description. And for the date, we have date ID, and then date, month and year. So for the sales, we have sales order ID, customer number, product number, store number, data, quantity and price. So for every entity, we need to also define the attributes. Apart from this, we need to also define the relationships. For example, what is the relationship between the product and the sales? What is the common column we have? Product and the sales. So here the product number, product type, product description is there, but here product number is a common column, right? So based upon the product number, we can get the data from the product as well as the sales. So these kind of relationships we need to maintain in the logical level. So this model is called as a logical data model. So apart from the entities, we need to also define attributes and their relationships. That is second one, logical data model. And now physical data model. Physical data model. So what is physical data model? So in physical data model, we have to go inside again, in deeper. So in physical data model, here we need to display all the tables and the columns and the keys. Apart from this, we need to relationships. These are already there in the logical model. And what else extra? What else we need to define as part of physical? So here we need to also mention the in detail like data types. So in the logical model and conceptual model, only we define events. In the conceptual model, we define only events. In the logical model, we define entities and their attributes. And physical data model, we need to have entities, attributes and their data types. So here just you need to remember, entity is a table. Entity is a table. So attribute. So attribute is nothing but column. And then every attribute we have a data type, right? So we here in the physical data model, we need to define the data types of these attributes. So here again in the physical data model, displays all the tables and columns. So when you come to the physical level, we will get everything, all the database tables we know, database columns we know, data types we know, table data, everything we will know. So here displays all the data, all the tables and columns, and apart from this, it displays the keys like primary keys, foreign keys, unique, not null, and all integrity constraint keys. And apart from this, here we need to also displays the data types. So this is the additional thing will come into the picture in physical data model. So now what is the difference between these three? In conceptual model, we will identify only entities at high level. In logical data model, apart from the entities, we need to also define the attributes. Attributes in the sense columns. And in the physical data model, we have entities and their attributes and their data types. So when you come to the physical level, we will get the complete database design. The complete database design will be completed at the physical data model. So basically the database designers, they will follow these things when you design a database. But why we are discussing this? Why we require this? Because whenever we do some ETL testing, we have to know the what kind of data model it is, what kind of entities are there, what are the attributes are there, what kind of data types we have. So these are all inputs for us. These are all inputs. So in going further, I'll talk about a document called a mapping document, a database design document or data model. So that contains this information. I'll show you how the document will be look like. So this information will be very much useful for doing the ETL testing. So that's the reason we covered this part: conceptual data model, logical data model, and the physical data model. Right, so now physical data model will be look like. So here we have events, product, date, sales, customer, stores. These are called events. And for these events we have a attributes. What are the attributes here? Product number, product type, disk. These are the attributes. And every event of every attribute we have a every entity we have a attributes, and every attribute we have a data type and their size. So here the product type is varchar of 5, product description varchar of 50, right? Here the date is varchar of 10. So this data type as well as the size we need to specify. So when you come to the physical layer, then we will get the entire data model design. So this is required for ETL testing. So when you start doing ETL testing, we need to refer a physical data model, not for logical and not for conceptual, because the logical and conceptual model doesn't have the full data. So we cannot use them for ETL testing. So only thing is we need to have the physical data model. If you have the physical data model, we will know the tables. Tables means entities. We know the columns. Columns means attribute. Okay. So everything we should have in the only physical data level. So we need to have this document before going to the ETL testing. Okay. So this is the basically the structure of physical data model. Now we will see the differences. Now all these conceptual, logical, and physical. Just now I have explained. So entity names available only in the conceptual model and in logical model. And even in physical model, entities becomes tables. Okay. And in conceptual model, relationships will be there. In the logical model also, relationship will be there. But when come to the physical level, it becomes the keys, like foreign keys and primary keys. That will define the relationship. And attributes on the sense columns. So in the conceptual model, we don't have any columns, we don't have attributes. When you come to the logical level, we will get the attributes on the sense columns. And physical layer, we have anyway columns. Attributes are converted into the columns. And here primary keys, foreign keys will be started from the logical model. We don't have in the conceptual model. And the table names, column names, and column data types. These three are very important for doing ETL testing. So these three things only available in the under physical layer and physical data model. Okay. So what is the table means? Again, this attribute will be converted as a table name in the physical layer. And here data types is additionally added in the physical layer. Right. So here again column names will be added in the physical layer. So tables, column names, and the column data types. So these are the three important things we required for doing ETL testing, which are available only in the physical data model. Okay. Fine. So these are all about the data model. What is the data model and what are the different types of data models? Conceptual data model, logical data model, and physical data model. Now move on to the other concept. In database, we always heard about the term called schema, right? We need to learn some few terminologies here in the database side. Let me write those terminologies first of all. So table, the first entity in the database is a table. What is table? A table is collection of data. it contains the rows, right? So collection of rows and columns. Collection of rows and columns. It is also contains the data. This is all about the table. This is the first entity in the database. Second, column. What is a column? Column is nothing, not column, field. Field is nothing but a columns. Like it collection, for example, if I say EMP, employee, employee is a table. So employee table contains the employee number, employee name, date of joining, salary, and etc. Right? They are called fields. So fields are nothing but a columns. Okay. Now, what is schema? What is schema? This term is very important for us. What is schema? A schema is defined as like it is a data modeling technique by defining the schema. Like it is collection of tables, fields, and their relationships. All together, we need to put as a schema. Okay. How we can define the schema? A database schema defines its entities and their relationship among them. That is a basic definition of schema. So a schema is a collection of entities. Entities are nothing but again tables. Entity is a normal generic term. The table is a technical term. Okay. So entities or tables. A schema is a collection of entities or tables and their relationship. This is basically called as a schema. So a schema is a collection of entities or tables. Entities are nothing but tables and their relationship. So what is the difference between what is the relation between one table is depending on multiple tables, and the same data, whichever data we are entering in the application, that data can be stored in multiple tables, and whenever we want to retrieve the data, we get the data from the multiple sources or multiple tables. In that case, we need to establish the relation between the multiple tables, right? So the schema is a collection of tables or entities and their relationship. So that's basically the definition of the schema. Now, so here we need to have how many types of schemas. So usually this schema picture will come into the databases also apart from the ETL testing. So what is schema? We need to understand what is schema. We understood schema is a collection of entities or tables and their relationship. So in database or in the data warehouse, how many types of schemas they will maintain? So they have maintained multiple schemas are there. Basically, most popular schemas are star schema and snowflake schema. I'll tell you what is star schema and snowflake schema. Let us follow this. We understood what is schema, right? So schema is a collection of entities or tables and their relationship. Now let us discuss what are the types of schema. So one is star schema and snowflake schema. So these are the most popular schemas we'll follow in the real time. Star schema and snowflake schema. So what is schema again? Schema is a collection of entities or tables and their relationship. So we will maintain these schemas in the different structure. It seems like a star, then we call it a star schema. If it seems like a snowflake, then we can call as a snowflake schema. That's it. Based upon the shape of the schema, we call it the star schema or snowflake schema. I'll tell you what is the difference between this. And before going to that, let us see what is schema, how it will be. Okay, then we will know what is star schema, snowflake schema, and how it will be. So before going to that, we need to understand one thing called as star schema, snowflake schema, right? So before going to this, we need to understand fact table. In ETL, this is very important. Star schema, snowflake schema is only for data warehouse. Okay, only for data warehouse, not for OLTP. only for ETL purpose, star schema and the snowflake schema. But here in the database side we have a schemas, but here we don't follow any kind of a schemas, just like a tables we have, and also we have a some relationships. It's a normal. And also if you have a we can also follow in the normal OLTP systems, but 90% of the times we won't consider either it is or a snowflake schema. Just statically the relations will be there in the tables and the data will be flowing. But when you come when you come to the ETL part, especially data warehousing system, so these schemas are very important. Okay, so now let us see, before going to that, we have we need to understand what is a fact table before going to the schemas. Okay, so in the star schema we have multiple tables. Let me draw the diagram, then you can understand how the star schema will be. So in the star schema we have a main table. This is the main table. Okay, and there are multiple tables will be there. For example, this is table 1, this is table 2, and this is table 3, and this is table 4, and so on. Multiple tables, and every table is related to this main table, the central table. Okay, and every table is having relationship between this main table, and between these two tables there is no relation, and between these two tables there is no relationship here. So every table is pointing to or relate with the only one table. So here this is called as a fact table. It contains the main columns, which columns having other tables also. So suppose it is a one table. It contains the ID is a basic column, and this table column is a having ID. And this table calling has some number, and this table is also having some number. So this is the way the main table contains only the columns. Those columns are 100% the primary keys, because these columns are belongs to the other table. So each column is belongs to each one of the table. So this is basically called as a fact table. There is only one table will be maintained, and all other tables are communicating with this table and relate to this particular table. So this is table is called as fact table. So whichever table is a centric table, basically that is called as a fact table. And this schema is called as a star schema. Why? Because it seems like a star, right? So this is a star. So this is based upon the shape we call as a star schema. So in the star schema, all the tables are belongs to a fact table. This is basically a star schema. Okay, so it seems like this. This is basically star schema. So here we have a products, we have a time, we have a customers, and we have a location. So different tables we have, and the central table is the sales items. So this table is this table is related with each and every table in the schema. Okay, so this is basically called as a star schema. Star schema. Now let us see the other one called as a snowflake schema. So in the snowflake schema, there is no. This is basically a little bit advanced than star schema. So it is also snowflake schema. Also is contains a star format, but is little bit advanced. So in this snowflake schema, so how the structure will be. For example, here also we have fact table. This is a fact table. Here we have a table 1, and here we have a table 2, table 3, and the table 4. Okay, so all these tables are connected to the central table, main table, right? This is called as a star schema. So this is also called as a fact table, right? Now this table belongs to some other two tables, and these two tables, this is another table 6 and table 7. These two tables are related to this one, and there are other tables. This is table 7 and the table 8, which are related to this table, and there are another tables which are related to this table, and so on. So here whichever table is a main centrally there, this is called as a fact table, and this table is belongs to the main table, right? Again this table is contains related to some other tables. So this table is called as a dimension table. This is called as a dimension table. This is also one dimension table. This is also dimension table. So this will expand like this. For example, this table is there. It is contains another table. Two tables are connected to this table. Another two tables are connected to this table. Okay. So this is basically snowflake schema. Snowflake schema. This will expand like this. Okay. This is called as a snowflake schema. Now it will be like this. Let me show you picture, then you can understand. So this is basically called snow schema. So here we have a sales item. This is a fact table, and products, time, customers and locations are related to sales items. Now again customers is related to customer type, locations are related to the territory. Now here the customers and the locations are called as dimensional tables. Customers and locations are called as dimensional tables. When we need to call dimension table, if table having relationship between some other table, then it is called as a dimension table. And whichever table is a centric table, which is having relationship between all the tables, is called as a fact table. So in only star schema we call as a fact table, but when you come to the snowflake schema, we every table whichever having relationship, that table called as a dimensional table or dimensional schema. Dimensional table basically. Okay. So in star schema we have fact table. In snowflake schema we have a dimension table. So what is dimension? What is fact table? Whichever table is connected with other tables, whichever table is having the relationship between other tables, that is called as a fact table in the star schema. And in the snowflake schema, whichever table is having the relationship between other tables, the table is called as a dimensional table. And here the customer type and territory type, there are two other tables are there here, and here the products and time is there. But these tables we don't call dimensional table, because these tables we don't have relate with the some other table. There is no other table depends on this table, but these tables are related to the sales item. But again there is no other tables or depends on products and time. Okay, so this is how we need to differentiate star schema and snowflake schema. So these are basically schema. So based up, these are all will be considered while doing the database design, right? So here the star schema and the snowflake schema. Star schema and the snowflake schema. So now let us write the notes. What is star schema and the snowflake schema? Star schema. First point. So this consists of fact table. As I said, a centric table there, right? So that table is called as a fact table. Okay, and dimension tables also contains around it. Table, fact table in the middle, and the dimensional table around it. So even in star schema we have a dimension table, because we have seen only the 5 tables, right, in the structure. Here this is a star schema. In this star schema, suppose if there is any other table is connected to this customers and location, it becomes the dimensional schema again, right? So dimension tables. So here we call, so the star schema consists basically called as fact table and the dimension table around it. So and another point, so here one more important point is a primary key. So in the star schema, if you see the star schema, so here the product ID, right? This product ID is available under products. So here the product ID is a primary key. Here this product ID is a foreign key. And here the date is there. So date is there again in the time table, right? Here the date is a primary key and here the date is a foreign key. So similarly, every field in the fact table should have a key. Centric table which is connected with all other tables. So how we can say here is a primary key or in fact table every column is a primary key and the corresponding column in the dimension table should be foreign key. So this is a star schema. Now when you come to the snowflake schema, this is a basically extension of star schema. Okay, so the snowflake schema is also consist of star. So here snowflake schema. So it is just extension of star schema. So it is also contains fact table, dimension tables and everything. Okay. So here the other point is each dimension table is normalized into multiple tables or multiple tables. So why I am saying this one is every dimension table again differentiate and we can create multiple tables because we don't store the data every data in the one table itself. So if any duplicate columns we have seen, we need to normalize and separate with the some other table. So this will always happen in the snowflake schema. Okay. So this is all about the schemas, star schema and the snowflake schema. So these schemas can be followed in the database and OLTP systems or OLAP systems. Okay, fine. Is it clear, both of you? So far, please confirm on the chat if you are clear. I'll proceed further. Yes, Sandeep. Tell me your question in the chat. Both seems to be same. Not exactly same because star schema is at lower level. As I said, snowflake schema is a little bit extension of star schema. Okay, so snowflake schema is star schema is not exactly same as snowflake schema, but snowflake schema is already as a star schema because this contains the star map. Okay, so you're saying dimensional in start and snowflake. Yes, that's the reason. So here don't confuse. Fact is nothing but only the difference between these two is in star schema we have a fact table. Okay, all other tables are belongs to the fact table. And snowflake schema we have a fact table and other tables, and sometimes other tables also act as a fact tables. So those tables are called dimensional tables. Okay, but in star schema the other tables don't act as a fact tables. There is only one fact table we have. Okay, that is the basic difference between star and snowflake schema. And the snowflake schema keep on enhancing. Okay, keep on enhancing. We can add multiple tables and we can split up the multiple tables and we can still normalize the existing tables and we can keep on increasing. But star schema is completely static. We cannot enhance it. If we are enhancing it, then it will not become a star schema. Again, this will become a snowflake schema. Got it? So actually we should not use this term here because star schema consists of a fact table in the middle and the dimensional table around it. Why I am saying dimension? Because here we should not say dimension table. We can say like tables around it. Suppose if any other tables are attached to this table, and then this table becomes a dimension table. Okay, so let me clarify it. Just a moment. So in star schema, we have a fact table. Okay, this is the fact table. Other tables are connected to this the fact tables. So this is a table 3 and table 4. That's it. There is no other tables or along with this. If there is any table is added, this table also connected to the fact table. This is a star. Simply, okay. Now, when you come to the snowflake schema, here also will be fact table there, and there is another table connected to this. There is another table connected to this. There is another table to this. In future, if there is any other table comes, that table can be connected to this. Suppose this is another table connected to this. This is another table. But there is no need of connecting 100%. We must connect to this particular table. There is no concept like this. We can connect to the tables for other tables also. So in that context, this table is called as a dimension table. So that is the basic difference between the star schema and the snowflake schema. So if you have new tables, we can still connect to the fact table, or we can relate to the other existing table. So this tree will increase, keep on like this. So, but in star schema, every table should connect it to the fact table. And if there is any table, if you connect to that table to the other tables like this, that becomes a dimension table. Okay. So almost 99% of these things are very similar, but only small change, a small difference. That's it. Is it clear now, Sandeep? Fine. So, Kavita, about you? Kavita asked question like, so does snowflake schema have multiple fact tables? We have only fact table, one fact table, and other tables, whichever tables is having the multiple tables connected, those tables called dimension tables. Dimension tables. Yes, we can have a fact tables, but again, it will be like this. Suppose this is a fact table. This is the table 1. This is the table 2. Table 3 connected. Okay, this is a normal star. Right, so now again there are multiple tables. Suppose this is one table, this is one table, this is one table. Here we cannot call this as a fact table. This is called as a dimension table. Okay, again these tables having the columns which are related to this particular table. Putting everything in one table, we are just splitting the multiple tables. That's it. So this is we don't call as a fact table. So this is called as a dimension table. There will be one table. All tables are connected to that. That table is called as a fact table. There will be only one fact table. It contains all the tables data, all the tables, columns, and information. Then only we can call as a fact table. Okay, but dimension table is not like that. Dimension table no need to have all the columns and primary keys, and no need to have the relation between all other tables. Maybe it has relation between one or two tables, but not all the tables. Okay, but fact table should have the relation between all other tables. That's called as a fact table. Fine. So now let us move on to the very important concept for ETL, especially slowly changing dimensions. Slowly changing dimensions. So what is this slowly changing dimensions? So this is a very important concept which we need to follow during ETL testing. Okay, so I'll tell you a scenario. For example, there is a customer. Okay, so he's living in some city. For example, the data will be like this. The customer data in the database will be like this. For example, customer number and customer name, year, and the location. So this is a customer data. So here I'll say like customer number is 1001, customer name is something called Rahul, and here for example 2010, for example is some year, and the location is something called as a London. Okay, so this is the data. So the customer data will be like this in the database. Now, when you move to this data in the warehouse, when you move to this data warehouse, it will be stored exactly like this, right? Customer number, customer name, year, and the location. So for example, he in 2010, this is the location, right? In this location, he is there. This data is moved on data warehouse. Now this data is there in the data warehouse. In the data warehouse, the data will be like this. This is data is updated in 2010. Now after few years, after later few years, it moved to some other location. So now he is updated his address in the tables or in the database. Now the data is moved to the actual data warehouse. But actually in the data warehouse, what is the record is maintaining? This is the record currently have. And now in other year, for example, 2013, he moved to some other location. Now the exact current data will be like this. Again the same record. Okay, he moved in 2013. This is actual current data. But in data warehouse, which record is there? Just a moment. Just please hold on. Let me share my screen. Now, can you see my screen? Right? Fine. So now here, this is the rule. This is an example. So a customer with a name Rahul who is living in London in some other year. So in this year, he updated the data. This is actual data, which is already moved to the data warehouse. Currently, this data is available in the data warehouse. Now, type 1 SED. So this is the rule actually. So while replacing this record, so the new record is different. The existing data in the data warehouse is different, right? So we need to either we need to delete the record, old record, or we need to replace the record, or we need to maintain the two records. That is our choice. So based upon the rules, we need to follow here. So type 1 SED, slowly changing dimension, is a rule. So as per the type 1, what we can do is replaces the old entry with the new value. So what is the old one? This is the old record. 10001 Rahul 2003 is the old record, is a London. Now what is the new record? 2005 is a new record. Data is changed. Number, name, location is same, but the year has been changed. Right? So now as per the first rule, what we need to do is when you dump the data into the data warehouse, just we are replacing the data. This is called as replacing. After replacing, we don't maintain the old record as per the type 1. So this happens based upon the requirement. Okay. Suppose if we have a requirement like we can still replace, then we can just replace. Sometimes the requirement like this, you can replace it, but we need to also maintain the old data. That is another requirement. So based upon the requirement, you need to apply the appropriate SED rules. So here, as per the first rule, what we need to do is we need to, when we dump the data, just we need to replace the value with the new value. If you replace only that particular value, we call this as a type 1 SED. Type 1 SED. Right? So slowly changing dimension. Type 1 slowly changing dimension. It replaces the old entry with the new value. This is the one example. Now let us see the second, type 2. In the type 2, we don't remove the existing entry. So old record, we don't remove it in the data warehouse. Still it is there. But we will insert the new record. We will insert the new record. This is the latest record. So in 2005, we'll also having the old entry. If I do like this, if we do ETL like this, this is a type 2 SED. Slowly changing dimension. Okay, so in this model, we should still have a old record and we are adding the new record. We are inserting the new record. And the third, type 3 SED. So original entry get modified to reflect the new entry. So in this way, in type 3, what we need to do is we have still the data, old data, year and the location, but whichever is modified newly, we will add them into the new columns. So still customer number, customer name, year, location is there, still there till this old data. The new customer is updated data. Now whichever is updated, we need to add two more columns, and we will move to the old data to the new columns. This is old year and old location, right? We have it added two new columns, and to move them, old year and location move to the old columns, and update the existing columns. Just like a update, move and update. So if I do like this, we will get the old data as well as the new data. But if I go for the second type, what is the problem here? First type, what is the problem here? If I replace the data, I lose the old record. That is a problem. And if you come to the second point, second method, what is the problem here? There are number of duplicates will be there. Suppose the customer is updated 5, 10 different times, 10 different duplicate records will be there, right? So that is a problem here, duplications. Now it will causing the slower performance. And then the third method, this is effective method. Type 3 SCD is effective method, because here we are not inserting the new records because there is no duplication. And the other one is we are not replacing the data, because if you replace it, we will lose the data, but we are not replacing it here. We have still the old data, and we still have the new data, and also we are not inserting the new row. The same row we are maintaining. Okay, so this is another rule. These are called as type 1, 2, 3 slowly changing dimensional rule. So while doing ETL testing, you need to follow these rules. Okay, is it clear, both of you? So these are called SCD, type 1 SCD value, and type 2 and type 3. So let me write the notes. So first, SCD type 1, SCD type 1. So in SCD type 1, so what is Sandeep question is, do we get info about which SCD they are? Yes, it is a part of requirement again. ETL, when you do the ETL part, right? So you will get the input documents. There is a mapping sheet and data model you will have. So that document contains this information. So what kind of things we need to use as per the requirement. Okay. Right. So now let us write the notes. So first of all, SCD type 1. So what is SCD type 1? It will basically replace the existing value. It will replace the existing value. So here replaces the old entry with the new entry. New entry with the new entry. So for example here I'll say customer number, customer name, year, and the location I have. So here the customer number is, for example, say 001. Customer name is suppose ABC, and suppose year is 2003, and the location is London. So this is actual record. And how it is replacing again? This is replacing the only the whichever data is updated. Suppose next is updation is 5. In the 5 they change the location. So here the location is also updated. This is the first row. Slowly changing dimension type 1. Now the second rule, SED type 2. SED type 2. So what is SED type 2? It creates a new entry. It inserts the new record, right? So it creates a new entry in the table. So if I say same example here, this is the actual table, and if I insert the table, how it will be? It will be add one more record. So the record will be like this. Okay, so this is type 2. And now type 3, SED type 3. So what type 3 will do is, type 3
will have the original entry just get modified to reflect the new entry. So original entry get modified to reflect new entry. Reflect the new entry. Right. So in this, how it will be? So the record is same. Now, if the changing happens, then it will add one more column. Apart from this, it will add. This will be same thing. But here, year is 2003, and location. Apart from this, here it will add old year and old location. It will add two more columns. So here the old year is suppose 2003 and the old location is London. So this will maintain. So this is a type 3 SED type 3. So when you do ETL part, we need to keep remember these particular rules. So again, I'll say that based upon the requirement, right? Ideally, we don't lose any history data. Okay, so that's the reason we always maintaining this. Again, this is a part of the rules. While doing ETL part, what ETL developer will do is they will consider these rules actually. Okay, so again we need to keep we need to replace the record, or we need to insert the new records, or we need to modify the existing record with the old as well as new data. So this is again up to the requirement. The SED, if we have changes up to 5 to 10 times exactly, this is good question. So if we have changes 5 to 10s, what happens is it will add keep on the columns with a time slot. Okay, here just for your understanding I'm giving the column names, but actually in the real time this will happen with the timestamps. Okay, so based upon the timestamps it will store the data. So in particular timestamp which location is there and which whichever is there, so based upon the timeline is important, right? Time slot will be updated as a column names. So here just for your understanding, just I have given as a old year and old location. Fine, so this is how it will be happen. So this is called as uh, SED type 1, type 2 and type 3. While doing ETL testing, we need to follow these rules according to the document. Now let us understand, for today this is the last concept. Let us understand ETL tools and BI tools. We need to understand this very carefully. We need to understand what is the difference between ETL tools and BI tools. What is BI? Business intelligence. So in the market, there are n number of tools are there. So for example, if you say ETL tools, what are all ETL tools available in the market? ETL tools. ETL tools examples, Informatica is one of the tool. Informatica Power Center. So this is the one tool we have for ETL. And we have a query search. This is also ETL tool. And Microsoft MS SQL Server SIS package. So these are all the different tools available in the market for doing ETL process. And apart from this, we have a BI tools, business intelligence tools. Business intelligence tools. What are the business intelligence tools? Basically, business intelligence tools are used for generating the reports and analyzing the data warehouse. So here we have uh, business objects and Cognos, right? Next, we have a Tableau, and like apart from this, we have Tableau, Cognos, business objects, and then there are n number of tools are there nowadays. PQ, and etc. These are all called business intelligence tools. Basically, these tools are generating the reports, and also those reports are used for analysis purpose. They will generate some graphs, and based upon the graphs, they can analyze the business. So, what is the difference between ETL tools and business intelligence tools? I'll give you the end-to-end structure here. So here, where the ETL tools come into the picture and where the BI tools come into the picture. So actually here in the real time there are multiple sources I am saying, right? So this is source 1, source 2, and source 3, multiple. We are getting all this data in one place. What is that one? This is data warehouse, I am saying. So we will dump all the data into the data warehouse. Okay, so actually in the real time, we don't dump the data directly in the warehouse. We have another area in between this that is called as a staging area. Staging area means we will get all the data in one place. This is not ETL actually. Okay, we will get all the data, dump the data in one place. From there to data warehouse, we will use ETL process. Here one time we need to do ETL, multiple sources to data warehouse. Now in the data warehouse, the data is ready. We need to analyze this data. So how we need to analyze the data? We need to generate some reports. Okay, so on the data warehouse, data is there. Under data warehouse, here we use business tools, either Cognos, business objects, Tableau, so etc etc. These are called as business intelligence tools. These tools are used for analyzing the data which is there in the data warehouse. Where the ETL tools come into the picture? ETL tools come into the picture in the here. So once we have multiple sources, and this is the target. So again, here the ETL is two different part. One is ETL developer, other one is ETL testing part. What ETL developer will do? ETL developer will dump the data based upon the mappings. So for example, here there is a table employee 1, employee 2 and multiple employees table data. Here 10 records I have. Here 20 records are there. Here 30 records are there. Here he will create one employee target data database and dump all the records into one table. And while dumping the table, all the data in one table, what are the rules and regulations we need to follow? So those rules will be implemented by developer. The rules are called as transformation rules. These rules are called as transformation rules. While dumping the data or while extracting the data from the sources to target, they apply these rules and completely they have extracted and put the data in the data warehouse. Now what ETL tools will do here is, ETL tester will do is, whatever data is extracted here, this data is accurately extracted or not based upon the rules. Even the developer also will extract the data based upon the rules on the document, and the tester also need to check the data warehouse against this document. It is accurately extracted the data or not. That is ETL tester job. A small difference between these two. And the ETL perspective, again, if you see, Informatica is a tool. Informatica is a both development as well as testing tool. Informatica is a whole. So here, this is Informatica is a ETL development as well as a testing. But it is very complex tool for installation and using. So people will go for query search. This is purely testing tool, ETL testing tool, not development tool. Okay. And then MS SQL, SQL Server, this is also ETL testing tool. ETL testing tool. This is the place where actually ETL come into the picture. So once the ETL is completed, data is ready in the data warehouse, then this data can be used by business intelligence tools. Okay, so now they will create some graphical formats and reports, and based upon the reports and the graph, they will analyze the business. So that is how they will use this. So that is the difference, basic difference between the ETL tools and the business intelligence tools. Okay, so here clear everyone. So this is all about the basic things. What is data warehouse? So we discussed a few points here. So what is data warehouse? And then we also discussed about different things, right? So what is data warehouse? What are the different features of data warehouse? Like what is OLTP and OLEP systems? And then what is the difference between database and data warehouse? And then what is the difference between ETL testing and database testing? Do we test in staging? No, we don't test anything in staging. So we need to test only staging to data warehouse. Okay. So now here, the ETL developer will take care of staging and everything. So from the staging to data warehouse, that is main ETL job will be there. Okay. And now we have also discussed data model. What is data model? What are the types of data models? Conceptual model, logical model, physical model. Then we have seen schema, star schema, snowflake schema. After that, we have seen slowly changing dimensional rules, E type 1, type 2, and the type 3. And then we have seen about the ETL tools as well as BI tools. Okay. So that's all for today. So rest of the concepts I'll cover in the next session. So any questions so far, Kavita or Sandeep? Okay, fine. So let's stop for today here. So I'll send this notes, recording, and the topics. What are the topics we are going to cover in all the sessions? I'll put in Google Drive, and I'll share with you. You can access this. Okay. So we'll meet on the next weekend on Saturday on the same time. Okay. Then bye everyone. If you have any queries, just please talk to offline. I'm available, always available on the Skype.